Hey guys, I'm turning my attention now to the tuner side of the 5KR radio. If you recall, when I initially went over this, I discovered that the volume rheostat was open, and I have not checked the audio transformer in here, and there are some capacitors that need to be replaced inside this box. And we got some nice old looks like spider nest in there I want to clean out and start tackling the rust on here. First thing I want to do is unsolder the wires on this, and it looks like these two screws need to come out, and examine this more closely. I unsoldered all the connections and loosened up these screws, so I think it's ready to come out now. I took some reference photos before I did this, so I can refer to them when I put it back in. Assuming that is, of course, that I can fix it and reuse it. Otherwise I'm going to have to replace it with something. Alright, so one big hunk of ceramic, and then lots and lots and lots of turns of a resistance wire. I suspect somewhere in there we've got a break. It's like around the outside there's a metal band to secure it, and there must be some kind of insulating material between this metal and the wire, otherwise the whole thing would just be shorted out. And the curious thing I was reading about this online is that there's also a secondary coil of resistance wire around the inside for about 1/3 of the travel. And I guess that crosses up against the outer to reduce the resistance through this range. Apparently that was an early attempt to make a non-linear control, so there's less resistance here. I imagine that was to create a linear increase in volume. Well, let's see, let's start out by, let's see if we can get this band off. The screw's kind of rusty, so yeah, that nut's kind of seized on there. Well, I'm going to examine this more closely and grab a multimeter too, and like connect one end here and start running the probe along and see if I can find where there's a break in this. Amazingly, it looks like there's just one break in this coil. So I've got my ohm meter clipped onto one end here, and as I run this probe around the outside, you can see we've got conductivity to there. And there, and so on. Until we get around here somewhere. Yep, there we lost it. Now we're still good. So somewhere right about here. We lost it. If I connect it to the other end, we're good up until just about that same point. And there, it's open. So right about in here. I was able to loosen up this outer band, so what I'm thinking I can do is pry this open and simply slip in a little shim. I have a bunch of gold-plated copper foil I pulled off of circuit boards, and I can just slip a bit of this down in between and to bridge the gap. The reason I would use something like this is this wire, nichrome wire probably, you really can't solder to it unless you have specialty solder like a silver solder, which I don't have. I removed the steel collar that holds this rheostat together, removed the rust, polished it up, and then installed a little sliver of gold-plated copper foil right over the brake, reinstalled the collar and tightened it down, and I think I restored continuity. I've switched to an analog meter because I think it's a lot easier to use when you're testing a rheostat. So first off, I want to check the two outermost lugs, which should be just a fixed resistance. And we got about 2K, which I think is about right. Now if I go to the inner and one of the outer lugs, the resistance should vary as I rotate the control. So we got about 2K, and as I rotate this, yes, it does indeed vary. And right about here is where the brake is, and I can cross over it, and the action's pretty smooth. So it looks like I've got a working rheostat now. Now, the nice thing about this is it should lift out as one complete unit, including the tuning drum and the cable, the pulleys, and everything. There's just, I believe, 3 screws holding it in place. I just finished unsoldering the connections. There's 3 wires here, 1 for each section. Then there's ground. As for the bolts, the screw heads up top are pretty rusty, but I can get at the nuts from down below. There's 2 there, and there's 1 more there. So I'm going to loosen those nuts up, and then hopefully the whole darn thing is just going to pull away. I thought I would be having to remove this drum and the dial cord and all, but I took a closer look, and the plate that this is attached to is not attached to this. It's attached to this. So this whole thing should just come right off. There we go. Was just one of the screws. Alright. Hey, actually, there's really not much rust at all underneath. It's a pleasant change. And boy, that makes it so much easier to have this all come out as one unit. I was not looking forward to trying to unstring this and have to restring it. Alright, so I can put that on the side somewhere so it won't get damaged. And focus on this, because this definitely is dirty and nasty and grungy under here. After removing the big variable capacitor, I then proceeded to very carefully remove the bank of RF coils. They're all mounted on a common frame, and actually it comes off fairly easily. So maybe a dozen solder connections that were all pretty easily accessible and easy to unwrap from the terminals here. Now I've got the fun task of check all these coils here and the audio transformers inside here. One thing that will aid me greatly in that is one of my YouTube friends sent me a copy of the RCA Red Book service info that covers these sets in really good detail, and they are nice high quality scans, so I can read all the finer points on these diagrams. So this is kind of a combination wiring diagram and schematic. So it actually, you see these 3 coils here, it actually looks quite a bit like these, same orientation and so on. In addition to these coils, there are actually a couple capacitors on here too. I wasn't sure what these things were when I first saw them, but I now know that for sure they are capacitors. So there's one there, and there's one on the side of this. And those correspond to these 2 caps as near as I can make out. So between the Redbook info and this I found on somebody's website that I had shown in an earlier segment, and this, which is the actual Brunswick 5KR info from Nostalgia Air, I think I've got all the component values now. It's crazy. So the RCA only tells you these 4 capacitors, no values on these resistors or capacitors up here. The Brunswick 5KR info from Nostalgia Air has the values for those caps, but no values on the resistors. Those I got from this diagram. So I use this as the one I'm going to work off of, and I wrote in the capacitor values. So there should be 1, 2, 3, 4 160 picofarad caps and a single 120. So I know where 2 of the 160s are on here. I'm going to have to hunt around and find the others. I think there are some up mounted around in here. Now as for this thing, that's this block here. That's the one I'm really curious about, because I imagine that would be very difficult to repair, whereas these, if need be, they could be rewound or spliced and whatnot. So what's inside this brown lump here? It's these 2 transformers. These vertical lines here indicate an iron core. So there's actually 2 transformers inside that block. They call it the AF transformers, or audio frequency transformers. There's quite a few wires that come out of it, I think 7 in total. They do indicate colors on here, blue, yellow, green, but over time they all kind of look the same now, so I'm going to have to carefully trace these out and check the resistance on them. Keep my fingers crossed. And then, assuming all that stuff is good, I want to get this block off. It's got 4 bent over tabs. I don't think they'll be too hard to bend up. Inside of here are 4.5 microfarad caps I want to replace or restuff. And all the resistors are mounted on the side of it, so if I can get this out in one operation, I hope to rebuild all these caps and replace all the resistors. So far so good, I'm happy to say. With the aid of this diagram, I was able to trace out the wiring to the audio transformers, and I wrote down the resistances that I measured on both of these. Around about 900 ohms on the primary and 4.5K on the secondary. Now I don't know what these values are supposed to be, but they seem reasonable. I'm now checking the capacitors. This one in particular right now, it should be 160 picofarad, and I'm getting around about 170 on my bridge, which is close enough to 160 given the tolerances of this device and the fact that you can just move these probes around a little bit and the reading varies a little when you're down in the picofarad range. So, a few more caps to test, and I need to check a few more windings on these coils. But yeah, so far everything checks out. Fortunately, the tabs were quite easy to bend up on this capacitor block. Now, as for getting it open, looks like there are 2 pieces of metal. One U-shaped piece going around this way, and the other going around this way, with an opening on this end. So, well, I have to get this end out, this cover plate and so on. There's some little tabs around the circumference, so I think what I'll do is try bending those up, and let's see if the insides come out. I got the tabs all bent back, but unfortunately the insides, I don't think are going to come out quite so easily. So I can either heat this up or pry apart the box. I am going to go for heat. Alright, there they are. I guess I'll try using a corkscrew like I did before to yank one of those out, and then the other one will follow easily. There we go. A little violent, but hey, got them both out in one shot. Alright, plenty of room to put the new capacitors inside. Here's the rebuilt capacitor. Pretty simple really. They're all 0.47 microfarad with a common negative lead going out through the middle. And simply pop that back in the box. I'll put a little bit of padding down below, something that doesn't conduct, a little bit of foam, and then crimp these little tabs back over.